question 4 of the 2012 AP exam, non-calculator. I think it's a pretty straightforward kind of problem. I'm starting to think that 2012 was a really good year to be an AP student, so a pretty straightforward problem here. The function f is defined by the radical of 25 minus x squared between negative 5 and 5. Now, actually, I'm going to go on a little side detour here because a lot of us tend to forget what this is, and I hope you guys remember that this is a half circle, which means that they asked us to integrate that. I'm not going to do a u sub on it. I'm probably just going to draw it out, okay? So anyway, let's find f prime of x. So that's relatively doable. F prime of x is going to be, okay, looks like there's two things happening here. So actually I'm going to write f of x first. I'm not going to do f prime. I'm going to do f of x, and I'm actually going to go and write it like this. I like to see the derivative problems like this. It helps me see the exponent better. And so I know that f prime is going to involve two layers of chain rule, right? The 1/2 is the outer layer. This is the car that's falling off of the bridge in Inception. And then the inner layer is going to be the 25 minus x squared, which is the hotel room with the elevator layer. Okay, so f prime is going to be 1/2 25 minus x squared to the negative 1/2. I have just derived the outermost layer, the uppermost layer, the car falling off of the bridge. Now, I'm going to derive the inner layer, which is the hotel room and the elevator. Be careful, the derivative of 25 is actually 0, and the derivative of negative x squared is negative 2x. And that's as far as you need to go for part A. I mean, what a wonderful problem to have. I like this problem. I wish I was an AP student in 2012. Okay, part B. Write an equation for the tangent line for the graph at x equals negative 3. So basically, we just found the slope. We found the slope anywhere, but we don't want the slope anywhere. The $64,000 question is, where do we want the slope? Thorntengruben! It's going to be at negative 3. So, what's the slope at negative 3? Well, that's going to be positive 1/2 25 minus, I'm going to call this 3 squared to the negative 1/2 times negative 2 times negative 3. And that should be negative, not that it matters, but I want to make sure that that stays right the whole way. Okay, cool. So, let's find out the slope. What I get is I get a 9, so 25 minus 9, so that's going to be 1/2 times, and I'm going to kick it down at the same time, so 25 minus 9 is 16, so that's really the square root of 16 on the bottom here, times 6. So those guys can knock each other out, so I get 3 over, hey, 4, cool. So that's my slope, and I kind of did this backwards from the way I normally do it. Usually, I would go and find the shell of the equation first, but since we already had the derivative, I figured I would just go based on our derivative first. So if I'm going to write the equation of the line, it's going to be y minus something is equal to 3/4 and then x minus negative 3, so it's going to be plus 3. Well, how do I find this y1? I'm going to take my x being negative 3, I'm going to punch it into the original equation. So what's the y coordinate? Let's find out. Well, that's going to be 25 minus negative 3 squared to the 1/2 power. Well, that's going to be 16 to the 1/2, so that's going to be 4. And that's as far as I need to go on this problem right here. Wow, part B, not that bad. Not that bad at all. Part C, they're asking us, let g be the function defined by g of x being a piecewise deal. And it's saying, is g continuous at x equals negative 3? Use the definition of continuity to explain your answer. Okay. Well, how do we test continuity? I'm going to make sure that the limits from both sides agree, and then I'm going to see what the function is there. Okay? Well, g of x is equal to, whoa, this is actually kind of weird a little bit. F of x if we're in between negative 5 and negative 3? Well, that means that I need to take the limit as x goes to negative 3 from the left side, and that's going to call upon f of x. Well, I feel like we already found out what that was, right? We did that in the midst of finding the y-coordinate. It's 4. It ends up being 4, right? And then if I take the limit as x goes to negative 3 from the right side of the, whoops, not f of x this time, it's going to be x plus 7. Right? Well, if I believe I'm in a good position to let x just go to negative 3, so I get 4 also. Very cool. Very cool. And from here, I have to find out what f of 4 actually, f of negative 3 actually is. And remember, because the definition of continuity says that the limits from both sides not only agree, but the function is defined in the place where they agree. And so all three need to sync up. These two pieces right here that we just found, it is a very wonderful thing that we found, but it is certainly not enough to establish continuity. I need to find out what f of negative 3 actually is. So if I look back at the little piecewise function, the equal sign is underneath the negative 3 on the top. So f of negative 3 is going to call upon that half circle we just found, which is 4. And that is why we can say, therefore, we can say that g is continuous at x equals negative 3. Boom. So that's the definition of continuity right here. And here's our explanation. All right, let's look at part D. Part D is saying, find the value of the integral from 0 to 5 of x rad 25 minus x squared dx. Now, if I was a lesser discerning person, I might actually fall for my own trap here, knowing that this is a half circle and trying to graph this crazy thing. But the reason why this is actually not a half circle is because of the x out front. Okay, so I'm actually going to integrate this by hand, and I am going to be using a u sub for it. This is a u sub problem. I'm going to integrate from 0 to 5 x rad 25 minus x squared dx. Alright, so let's u sub this thing. I'm going to let u equal 25 minus x squared. du is going to be negative 2x dx. In other words, negative 1/2 du is equal to x dx. Now again, why am I u subbing this one again? It's because I see a function and I see that function's derivative. At the same time, I'm going to reposition these limits of integration. If I punch a 0 in, I get 25. If I punch a 5 in, I get 0. Oh, this is a little bit treacherous. A little bit treacherous. I'm going to have to pay a little bit more attention here. I have negative 1/2 from 25 to 0 of, hey, wait a second, what about this x on the outside? X dx becomes du. And all I have on the inside is rad. Well, 25 minus x squared was my original u, so it's rad u du. Now, I'm going to go ahead and reposition those limits of integration one more time. I'm going to go from 0 to 25, which means if I reverse my limits of integration, I have to kick out a negative, which means the negative being kicked out of the integral, and the negative here for the 1/2, they die. And I'm going to say u to the 1/2 du. So what I get is 1/2 times u to the 3/2 times 2/3 on the interval from 0 to 25. Well, the 2 on bottom and the 2 up top, they die. So I get 1/3 u to the 3/2 from 0 to 25. What is that? Well, that's 1/3 25 to the 3/2 minus 0 to the 3/2 And believe it or not, that actually is as far as you need to go. If you really wanted to go a little bit further, though, the square root of 25 is 5. Cubed is going to be 125. So I'm thinking 125 over 3 is the final answer. Pretty straightforward FRQ. Alright, we'll see you guys in the next one.